inequalities. And it's just like the linear ones. There will be an area to satisfy the inequality. And just like before, these two use dashed, and these won't be lines. They'll be mostly parabolas. There's one or two that are polynomial cubics or to the fourth degree. And if it has the little bar underneath it, just like before, it's solid. And remember before we said if it was above the line, it was greater than, and below the line, it's less than. This time it's above the x-axis is greater than, and below the x-axis, our line is the x-axis. It always is the x-axis in this one. So it's below the x-axis is less than or equal to, above the x-axis greater than or equal to. Those are your rules. Let's look at a problem. This is the first example. And you have, this is one like you're going to have, x minus 1 times x plus 4 is less than 0. So I'm thinking about my boundary, and my boundary is going to be dashed, and I'm going to shade below the x-axis when I get through. But I don't have to shade any. In this one, they're not asking us to shade. They're asking us to tell it an interval form where the answer is. So it's a little bit different. So we don't shade. We just look at our curve and see which part of the curve is below or above. So we're looking at below the x-axis, and it's dashed. Okay, so that's kind of what we're going to look at. To get the boundary, just like before, we set these equal to 0. We have x minus 1 equals to 0. We get x equals 1. X plus 4 equals to 0. Gives us x equals to negative 4. Okay. Those are called critical values. They're also the x-intercepts. So what I'm going to do is go to my graph, and I'm going to put x equals 1 here, x equals negative 4 here. Then I'm going to grab my calculator, and I'm going to graph this one that says equal to. Somebody must be outside. X minus 1, x plus 4. We graph it just like that. I don't have to do anything. And you can see it's a little parabola that goes down. And I'm going to sketch the graph. Oh, I want it dashed. I always forget to make these dashed on these parabolas for some reason. Okay, now then, the question that I want to ask you is if you can see the part of the graph that is below the x-axis. Can you see that? It's below, right in here. Do you see that? That section that I just colored greenish? That's where it's below. Here's the x-axis. And this part of the graph, from here around to here, is below it. So my answer, going left to right in interval notation, would be between -4 and +1. That's my answer in interval notation. Between -4 and +1, that graph is below the x-axis. So it is less than 0. Any questions on that? Did I lose you? Are you good?
Good.
Billy, did you catch that? Some of you look pretty blank. Are you okay?
Yes, ma'am.
Okay. Okay.
This is better than 8.4. I didn't like 8.4.
Yeah, this one's a little easier. Okay, let's try the next one. The next problem is a little more complicated than that one, but not much. It is x squared plus 4x plus 7 is greater than or equal to 5x plus 9. Now, I really can't do much with this until I get a 0 over there. So then I can change I can do my other things. I'm going to subtract this 5x from both sides. And I'm going to subtract a 9 from both sides and see what I get. X squared minus x minus 2 is greater than or equal to 0.
Still going to be a parabola.
It is going to be a parabola. And I want above the x-axis. And it's a solid line or solid parabola.
Okay.
And so to get my boundary, I'm going to put x squared minus x minus 2 equal to 0 and see if I can factor it. Let's see, I have to subtract factors of 2 to get 1. What is that going to be? 1 and 2? It's got to be. So 2 is going to be negative and 1's going to be positive. Then I set each one of those equal to 0. I get x equals 2. X equals -1. Okay? So when I do my graph, I've got a -1 and a +2. And I'm going to grab my calculator and see what that looks like. I can do the original, this one right here. X squared minus x minus 2. And I can see when I graph it, get a nice little curve. And this time, I want the part that's above the x-axis. So the part of my graph that's above is right here and right here. Do you see there where I made it fatter with the blue? So now I've got to figure out how to write that in interval notation. So think about it. I'm going left to right, and I'm using these x's, and it's going to go up and out and up and out and up and out. So what is my lowest x value over here?
-1.
-1 is right here. You would start right here if you were using -1. Remember, like this one's like -1.5, -3.
Negative infinity.
Negative infinity. This thing is going to keep going up and up and out and out. And so if I was way up here somewhere, then I might have a negative 50 for my x value. And if I kept going up and up and up, would end up with negative 100 as my x value. So my x values are from negative infinity up to, what is this value right here?
-1.
-1. Now, do I want to use a bracket or a parentheses since it's solid and it has this equal to thing in here?
Bracket.
A bracket. Do you remember doing that before? Now, this part of the graph is underneath the x-axis, so I don't use it at all. It would be less than 0. But once I get started over here to this one, what point is that?
2.
2. Once I get to 2,
Positive.
it goes to positive infinity, and you can put a union in between it.
Are we doing this because it's a greater or equal to? I'm like lost.
Yes, you're doing it, you're shading above because it's greater than. Remember those rules at the beginning?
No, but is that why you're writing that notation? I'm trying to figure out why we didn't do that on the first one.
This notation?
Well, the notation, the first one was just the points. I'm just confused on why we're doing
Oh,
it.
no, it's not a point. This is an interval. This is an interval from this 4 to this 1.
Okay.
It's this whole interval in here. It just looks like a point because it just has the 2 numbers. But this is interval notation. It starts at a -4 for the x value, and it ends at 1 for the x value. And it doesn't include those points because there's not an equal to underneath the less than.
Oh, okay. Okay.
And it makes it look like a point, but it's not a point. Good question. Be careful on these greater thans. All right, let's try another one and see how much more complicated they're going to get. Let's look at this one. This one is x squared plus 12 is less than 4x. And before you do anything, you need to get a 0 over here. So you subtract that 4x from both sides. And now you have x squared minus 4x plus 12 if I put it in the proper order. And then I would have a 0 over here. So this is dashed, and it's below the x-axis because it's less than. So the next thing I do is set this equal to 0 and see if I can factor it to get my boundary points here. Let's see, I have to add factors of 12 to get 4. Can I do that? -6 and a +2 would mean I have to subtract those, not add them. That won't work because then my negative.
Oh, yeah, because of the sign.
-12. So this will not factor.
So we'll have to do the, what is it, the quadratic
formula. But let's look at it. Maybe it doesn't even cross the x-axis. If it doesn't, that could be good for us. Let's see. X squared minus 4x plus 12. Look at that. Let me change my zoom to 6 here and see if I can get a better picture of it. Nope. That little thing is up here somewhere. Does it go across the x-axis at all?
No.
Is any part of the graph less than 0, less than the x-axis?
No.
No. So it will not factor. I should have dashed that boundary. I always forget. But it doesn't matter anyway because there is no solution to this. It doesn't go down here across the x-axis at all. So there's no point that it's below the x-axis. No point where it is below the x-axis. So that is called an empty set, and I think he actually introduces this symbol, which means the empty set. I know you've probably
This
seen
was
it.
the best problem ever.
You like this one?
We should have one of these on the final.
Well, I'm sure there'll be one of these kind on the final. There's an inequality that I think the last question is an inequality. Maybe not, but I know one of them is. Okay, let's do one more. This is a polynomial one. And it is negative x cubed minus 5x squared is greater than negative 4x minus 20. So this is a cubic. So let's get this thing equal to 0, or the 0 on that side. Okay, let's see what we've got here. Negative x cubed minus 5x squared plus 4x plus 20 is greater than 0. Okay, now I can put my stuff in. I'm looking for above the x-axis, and I need it to be dashed. So, I wonder if this thing will factor. Let's see if it will. I can factor out a negative x squared, and I would have an x plus 5, I think. And I can take out a 4, and I'll have an x plus 5. So now I have an x plus 5 and a negative x squared plus 4. Well, that x plus 5 is okay, but that negative x squared plus 4 is not okay. I need this negative to be in between here and not where it is. So if I mess with this thing and I take out a negative 1, I would have an x squared minus 4, which is what I want, because that will give me an x plus 2 and an x minus 2, because that's a difference of 2 perfect squares. So let's see what I have. I'm going to move that minus 1 out to the front and put my x plus 5 in there just because it's prettier. And then I set, this didn't have an x on it, so I don't have to set it equal to 0. But this one, and this one, I have to set equal to 0 to get my values. X plus 5 is equal to 0. Gives me x equals negative 5. These are actually the zeros of the function. X equals negative 2. And x equals 2.
I got a question.
Yes, ma'am.
Because I was writing them down and you write pretty fast.
That's
okay. So I had a question. Okay. Do you know how, like, right when you factored, because it's an AC, or what do you call that, binomial or something, not like right under, like right there where it says x in parentheses, x plus 5, parentheses, negative x to the second plus 4. Okay, right under that, why did we multiply that by negative 1?
We didn't multiply it. We took out a common factor of negative 1 because I wanted my binomial to look like a difference of squares like I'm used to seeing. So if I take out a negative 1, it'll change the sign to a positive, and it'll change this sign to a negative. And this looks like my old difference of two perfect squares of
Oh, yeah.
x plus 2 and x minus 2. And this -1 I can just take out here in front of the whole thing, and it doesn't have an x with it, so it's not going to change anything.
Okay.
Okay, so let's see what we've got here. We've got a 0 at 2, a 0 at -2, 3, 4, 5. And I'm going to go ahead and show you kind of what it looks like, and then I'm going to graph it and show you the two. It looks like one of your normal cubic curves, but I got to remember that I want the part that is above, because my problem started out as a greater than. So I'm looking above the x-axis is what I want. So I'm going to graph it too, just to make sure my graph is correct. And I can do it from the very start up here after I've set it to 0. I can do it from there. I can't do it from this first one. I can, but there's a trick to doing it that way. -x³ minus 5x squared plus 4x plus 20. I'm going to graph and see if it looks kind of like what I think it's going to look like. Yep. Looks like a cubic curve there. It's crossing at -5, -2, and 0. If I want to double check, those are my -2 is 0, -5 is 0, and 2 is 0. So those are correct values. Now my question is, where is this graph above the 0, the x-axis? Well, this is the x-axis. This part of it's above, right here. And this part from here over to here is above. Do you see that? The part that's purple there is above the x-axis. This one is below the x-axis, and this one down here is below the x-axis. So I want the part that's above the x-axis. And I have to put it in interval notation.
Negative infinity. Negative infinity to 5 to -5 with a bracket at -5.
Not a bracket, because this is a dashed line, so it would be a parenthesis.
That's right.
Okay.
A parenthesis.
Now, how do I skip over and get from here over to here? This one was -2, and this one's +2.
Positive.
So -2 to +2. That's the part that is above the x-axis, which would be greater than 0. Okay, you straight on those?
They always wanted it.
Do what?
Is this how they will want it, like in the black?
Yes, they always
in
want it in
Blackboard, it'll
interval.
be like this.
They want it in interval notation.
Okay, thank you.
And these are not
Okay.
multiple choice. You'll have to actually put these in there. Okay. All right, let's look at some of the problems. That we're going to have from this section. The first part of it is just factoring. And if you already know how to factor, you don't have to watch this part if you don't want to. The first part is to solve, and you have to factor to solve. So it's 7b plus 3 times 4b minus 12 equals 0. So you set each one of them equal to 0. We've been doing this all night. And you figure out what they are. Let's subtract the 3. Then we'll have a 7b is -3. Divide the 7. B is -3/7. Add 12 to both sides for the other one.
Is this the support?
Yes, this is the support. And there's a blank there. It says the solutions are blank. So you're going to have to put -3/7, comma 3. Don't put a parentheses around it or they'll count it as a point. Somebody did that on the quiz and they meant for them to be points, and I had to go back in and count that for you. Okay. Do I need to do 2 and 3 that are factoring problems, or you want me to skip to one of these that's like we did tonight in class?
Can we get back over asymptotes?
Can we go back over asymptotes? Sure. What would you like to do with asymptotes tonight?
I don't know. Just from the beginning, that seems to be the most complicated thing out of everything we've talked about in the past week and a half.
Okay. Well, I can do some asymptotes if you want to. Let me find some that we have done. Do you have one handy? Let me see if I've got one on this list.
Hold on just a second.
Got my book in the other room that's got all of our work on it. I didn't bring it in here with me tonight.
This one's pretty straightforward. It's f of x equals 1 over x minus 3 squared.
Quantity squared? Like that?
And then
What do they
I guess
want?
just run through everything, vertical, horizontal.
Let's do domain. Domain is where you set this one not equal to 0. And there's 2 of the same one, so you don't have to worry about doing it twice. So x cannot equal to 3. Okay. All right, now let's do vertical asymptote. There it is right there. To do your vertical asymptote, you set it equal to 0. X equals 3 is your vertical asymptote, and that's the place it's undefined, so that makes sense. Let's do the domain in interval notation. -infinity up to 3, union 3 to positive infinity, because they usually ask you for it in interval notation. Let's do horizontal asymptotes. Okay, a horizontal one, and you have to know that this is 1x to the 0 on the top. If it's just a number on the top, then it's x to the 0 power. And on the bottom on this one, I don't know if you can see it or not. Maybe I better multiply it out for you. This is really x minus 3 times x minus 3, which is x squared minus 3x minus 3x plus 9. So in the bottom, you have an x squared. So your EOM is 0 and your EN is 2. So EOM is less than EN. So use your sheet and tell me what your horizontal asymptote will be if your top exponent is smaller than your bottom exponent. What is it?
Sheet. Okay. I knew I was missing a piece of this. Where did we find this sheet?
there's a sheet that you have that has all of the information about asymptotes on it.
Hold on, let me go find that sheet. We can come back to this because I was not aware of this material.
Ah, here it is. Looks like this. And it's written out, and it's on your assignment, and it's on the lecture.
I'm
It's
gonna
on
go
the-
ahead and print that out.
And so if M is less than N, what is the equation of the asymptote?
Y equals 0.
Yep.
So the horizontal asymptote is Y equals 0.
Yeah, if you're missing that little part
Can you
right
hold
there.
that up for a second? Can you go back,
It-
hold that sheet back? I was writing something down on that.
It might be.
Thank you.
I'd have to revisit all these problems I've been trying to do with that information. Like I
If you're
said, a piece
missing
is
that,
missing.
if you're missing this little piece right here where M is less than N, M is equal to N, and M is greater than N,
Yeah,
that will make a whole big world of difference in your assignment.
absolutely.
And the M and N are your top exponents, your leading exponents of your leading term. That's why we did all that stuff about the degree of the polynomial, because that degree in the top and the degree in the bottom are the ones you need to use for this.
I was wondering when the lead that was going to come back into use.
And the second one is if they're equal, then you have to use the leading coefficients, the A and the B, and you put Y equals A over B. And then if the M is bigger than the N by a degree of 1, you have an oblique one. And that's when we got bogged down tonight in that long division, because you have an oblique asymptote. You use it by long division. Yep,
And
that's,
that's a very specific occurrence. It's easy to pick out when you're going to have an oblique.
oh yeah.
I think, no, because all the problems I were getting, I didn't understand how the horizontal asymptotes work. Like the vertical ones are pretty straightforward. And the oblique, complicated, but I know how to find it.
Well, it's the horizontal piece you're missing. There you go.
All right. Yeah, I found the sheet. Thank you.
Okay. All right. Let's do some of the problems off of 8.6 that is for, let me see if there's one that's hard enough that we can do from 8.6 that's inequalities. How about this one? This one's a little bit harder inequality. It is 24x minus 144 minus x squared is less than 0. So it already has the 0 over there, so I'm thinking below the x-axis. I'm thinking dashed. And then I've got to figure out how to factor this thing. So this is another one of those when my x is squared, and I sure wished it wasn't. So I'm going to play with it a little bit. I'm going to say negative x squared first plus 24x minus 144. And I'm going to set this one equal to 0. But remember that when I graph it, I'm going to need to graph that one right there, because it's going to be an upside down parabola because of that negative x squared. Okay. So let's take out a -1 like we did on that trick a while ago, and it will change the signs on everything and make our little factoring section easier. Let's see if we can factor this. X and X, and I've got to do 144 so that when I add, I get -24. Can you think of what that might be?
12
It's going to be
and 12.
-12 and -12.
It's called the double root right there because they're exactly the same. Let's see what happens when we do this. We get an x minus 12 is equal to 0. So x is 12. So what I need to do is kind of look to see what this thing looks like. I'm going to come over here somewhere to 12. I know 12 is a point there. Look at it and see what it looks like. You can actually put it in just like it is given to you there. The calculator will turn it around like it wants to. And I'm not going to see the point because I can see the edge of it here. So I need to move my window over so that I can see it. Let's do an X maximum of 20 and see what happens. See if we can get a picture of it. Yep, there it comes in there. See that? And at 12, that parabola is dashed, Brenda. And it's just touching it. Just touching it. You see that? So we want the part that is below the x-axis. Now let's think about that. If it's below the x-axis, then I'm looking at all of this area in here and all of this area in here. That's all below the x-axis. So why wouldn't I just put the whole curve? Why can't I just put the whole thing, the x squared minus 24x plus 144 with a minus in front of it?
Because it's 3 point.
Because it's what?
Or one is actually at the x-axis and it's
Yes.
3 points.
And if this had been less than or equal to, I would have done the whole curve. But because this is less than, it does not include this point up here. Does not include the 12 because it says less than. So it doesn't include the 12. So how can I possibly do this in interval notation and skip the 12? Does anybody know? Negative infinity.
Just to put a union.
You skip the 12 by putting a parentheses at the 12 in both cases. And that will skip the 12. Isn't that cool?
So if we were adding the 12, it's a bracket. But since we're skipping it, it's a parenthesis.
That's correct. You're right. You are right. Okay, let's try another one that's upside down because the upside down ones are hard. I'm going to do this one. I'm going to show you that you can do this one without changing that sign. It's just easier to change the sign. I'm going to do this problem 5. It's less than or equal to 0 and is backwards. I could turn it around like I did a while ago. I'm going to show you could do it without doing that. I want below and I want it to be solid. Okay. So it's going to include those x-intercepts. You could go ahead and factor this. This is a difference of 2 perfect squares. I could have done that on the other problem that we had. So if you forget how to take out the -1, you can factor it this way. Now, 1 plus x is equal to 0. So x equals -1. 1 minus x equals to 0. So negative x equals -1. Divide out your -1 and x equals 1. So you have a parabola and it's going to cross at 1 and -1 and it's solid. Okay. And I want the part that's below the line. So I'm looking at the part that's below the line. So it's down here, this part. And down here on this part, not the part that's above the x-axis. Anybody have an idea how I can do that in interval form? What's the lowest x?
Negative infinity
Okay, negative infinity to
to -1
-1. Do I use
in
a
a bracket
Good. Why do I use a bracket?
because it includes it.
Because it has the equal to, it includes it. Okay.
And then a union
Uh-huh.
and another bracket,
Uh-huh.
1,
Uh-huh.
positive infinity, parentheses.
Good job. Okay, now see, you can do those by factoring them with the x behind. But if you wanted to, you could just take out the negative. Just remember to graph this one up here because you want your parabola to have that negative value. It's upside down. It's an upside down parabola. Okay, let's see. In 5.1, let me see if there's anything that's hard in 5.1. 5.1, I didn't even do a lecture on it because it's stuff we've done already. Let's look at number 2. Number 2, find all numbers for which the rational expression is undefined. See, this is what we're doing. All of it's connected. So you're going to start seeing these things over and over, and it'll even get worse next week. You're going to say, how many ways can you do the same thing? So you don't
That's what makes me get like
it makes you
confused.
crazy. Now, you don't have to worry about holes in the graph because you're not graphing this. And if there's a hole in the graph, it's still going to be undefined. So just mess with the bottom. Don't worry about the top, just the denominator. So factor the denominator. Do you understand what I said? So it doesn't matter if there's a common factor in this and this or not, because the whole is still undefined. And you're not trying to find vertical asymptotes. You are trying to find the places that's undefined. So just use the bottom and factor it and see what happens. Z squared minus 16z plus 63 equals 0. Have you been thinking ahead to see what numbers would add factors of 63 to get 16?
9 and 7.
Good. 9, z minus 9, z minus 7. And if we set those equal to 0, those will be our undefined spots. We can say not equal to 0 like we do on our domain. That would be okay too. So we've got a 7 and a 9, and this is the way it looks in your assignment. The expression is undefined for blank, and they want you to put 9, 7. Okay. The other things are the same thing. It goes from being the expression undefined to finding the domain. So that's when you do want to be for sure set it not equal to 0. Find out those numbers that are not equal to 0. Okay? All right, now then, time has come for me to open this up for any question anywhere in this whole set of problems that you need some help on for from 8.1, I think. We started with 8.1 in this section to all the way to tonight. Anyone have any questions about any? Yep, it's 8.1, 8.2, 8.3, 5.1, 8.5, 8.6. Are you crazy after doing that long division tonight? Did it make you crazy?
No, I asked the other night, and so now I'm set. I'm good.
Okay. All right. Anybody have any questions that you need help with? Anything that you don't understand that I need to do another problem like it? Did Danielle come in?